Hey guys, welcome back to my channel. Sorry for the delay between this follow-up video and my last video. I had a couple of film shoots and then I went on vacation, so I'm finally just catching up with myself and this channel. But as promised, today I will review the second book that I mentioned in the last video. This book was one of two that I read while we were filming Hacking Reality, and some of the ideas in it really stuck with me, so I wanted to share some of those ideas with you guys today. The book is Michio Kaku's The Future of Humanity: Terraforming Mars, Interstellar Travel, Immortality, and Our Destiny Beyond Earth. Now this book, which came out in 2018, is quite a bit longer than the Neil deGrasse Tyson book that I talked about in the last video, and there are some crossover topics like our frenemy, dark matter, but this book really focuses on space exploration in terms of its necessity and practicalities. And I really liked how boots on the ground this book felt. Like, if we were really going to do these things, this is what it would be like. Now, Dr. Michio Kaku is a pretty famous theoretical physicist. I'm sure you guys recognize him. He's definitely done his TV time. And this book starts with the incredibly upbeat premise that extinction is the norm for all life forms. Dr. Kaku points out that 99% of all species become extinct, and that in order to avoid extinction, organisms must either leave their environment, adapt to it, or die. Earth has already faced 5 major extinction cycles, where 90% of all life forms vanished. So his idea is kind of alongside Carl Sagan's idea that humans, for the sake of their own survival, should become a 2-planet species. So he says the holy grail of astronomy is to find another Earth. So as we're entering this new age of space travel, the book basically breaks down how we can accomplish this behemoth in 3 parts: creating a moon base and colonizing Mars, moving beyond our solar system, and how we will have to modify our bodies in order to do this. The book begins by going through the history of rockets and our first attempts to leave this planet, and the history of this is really interesting. I don't know how familiar you guys are with the history of rocket science. I didn't really know a lot about it aside from some of the famous names. He talks about Robert Goddard, an American physicist who perfected the first liquid multi-stage rocket. In 1912, he used the rocket equation from the Russian physicist Konstantin Tsiolkovsky to determine the maximum velocity of a rocket that included considerations for velocity and drag. Tsiolkovsky was a huge inspiration for Goddard and came up with his rocket equation, really the first of its kind, right around the same time the Wright brothers were messing around with gliders in Kitty Hawk. Tsiolkovsky also famously said in a letter in 1911, "The Earth is our cradle, but we cannot be in the cradle forever." Goddard also introduced the idea of rocket fuel being a liquid fuel rather than a powder, and the use of gyroscopes to keep a rocket on target. In 1926, Goddard completed the first successful launch of a liquid-fueled rocket in Auburn, Massachusetts. They dubbed the rocket Nell, and Nell flew 41 feet in 2.5 seconds and landed 186 feet away in a cabbage patch, which apparently is now a national landmark. So, go see Nell, you guys. Dr. Kaku also talked about Wernher von Braun, who really moved rocket development to the next level. Von Braun was a German engineer who famously developed the V2 rockets, was the chief architect of the Saturn V launch vehicle, which propelled the Apollo spacecraft to the moon, and apparently was a bit of a Nazi. Yeah. The V2 rocket was developed for the Nazis and stood over 46 feet tall, could travel over 3,500 miles per hour, and had a range of over 200 miles. And this was only about 15 years after Nell, so pretty impressive all the way around. Apparently Hitler thought the V2 rocket would be an awesome vengeance weapon against the Allies, and after the war, von Braun defected to the US and started working for NASA. That's a whole big long story, but if you want to learn more, I suggest you Google Operation Paperclip and get ready to go down a whole big internet rabbit hole. Then Dr. Kaku covers the history of the space race and the effect that that had on education in the US. The Soviets at the time accomplished a whole lot of firsts in the space race. They were the first to send an animal to space. They were the first to get those animals back safely. They were the first to send a rocket past the moon, the first to send a rocket past Venus, and of course Yuri Gagarin, the first man to orbit the Earth. The conclusion as to why the Soviets were basically kicking our butt when it came to the space race really came down to education. They were better educated than us when it came to the sciences. So there began this big push for the sciences. It became a national duty to become physicists, chemists, and of course, rocket scientists. By 1966, 5.5% of the federal budget went to the lunar program, which consisted of the Mercury, Gemini, and Apollo missions. Von Braun, who I mentioned earlier, oversaw the construction of Saturn V, which was the biggest rocket ever built at the time, over 60 feet taller than the Statue of Liberty. A little personal tidbit, I saw the Saturn V rocket where it now resides at the Johnson Space Center in Houston, Texas a couple of years ago. Really exciting, definitely worth checking out. Eventually, costs became too much and beating the Soviets were no longer a priority, and the shuttle program was a cross between commercial and consumer interests, sort of satisfying no one. In 2011, President Obama canceled the Constellation program, Moon program, and Mars program. All were defunded in the hopes that the private sector would make up the difference. And now, ironically, American astronauts had to hitch a ride with Russian cosmonauts every time they wanted to go to the International Space Station. In 2015, NASA declared long-term goals for their astronauts to go to Mars, and Jeff Bezos and Elon Musk jumped in with their respective space firms, Blue Origin and SpaceX, and have not stopped talking about space travel ever since. Dr. Kaku also does a really good job in this book of explaining NASA's obsession with the Moonbase, which is a word that I cannot get out without it just kind of sounding silly, like Moonbase. But this book did a really good job of explaining the value of a base on the moon when it comes to space exploration. In the 1990s, large quantities of ice were discovered on the moon in the southern hemisphere in craters that are below freezing due to the near perpetual darkness of the southern hemisphere. The origin of the ice probably comes from comets, which are made of ice, dust, and rock. So when a comet strikes the moon, deposits of water and ice are left behind. And the chemical makeup for water, as we all know, is H2O, 2 hydrogen atoms and 1 oxygen atom. And oxygen and hydrogen just happen to be 2 of the principal components of rocket fuel. So essentially, Dr. Kaku is saying that the moon base could serve as a cosmic gas station for space exploration. Water could also be used for drinking purposes or to create small agricultural farms on the moon. He also talks about what living on the moon would be like. 1 lunar day is equivalent to 1 Earth month. So on the moon, you have 2 weeks of daylight and then 2 weeks of darkness. So in the beginning, lunar probes would have to do all the resupplies for oxygen and water to start us off, and especially large banks of batteries because of all the dark. He also says communicating would be easy because it takes 1 second for a radio signal to get from the moon back down to Earth. But also that mining would probably be necessary for drinking and for oxygen. But since the moon's gravity is 1/6 of Earth, the heavy machinery that would be needed for mining would be a lot easier to move. But we would also have to contend with the radiation danger that would come from spending months on the moon. And this radiation thing is going to come up a lot when it comes to space exploration. Okay, then Dr. Kaku gets into traveling to Mars and all of the dangers that come with that. He actually discusses the so-called Mars jinx, which I had never heard of before, because apparently 3/4, 75% of all the probes that have been sent to Mars never made it. Compare that to NASA's overall launch failure, in which only 2 launches, Challenger and Columbia, out of 135 launches, failed. That's a 1.5% failure rate. Overall, the fatality rate for astronauts is just 3.3%. So what's the deal with Mars? Why is it so hard to get probes there, and what will be so hard about getting people there? Well, Dr. Kaku says simply, the vast distance. It took Apollo 11 in 1969 3 days to get to the moon. It will take 9 months to get to Mars, 2 years if it's a round trip. The effect that that distance has not only on probes but also on astronauts is a huge obstacle. There's the atrophy that the astronauts will experience, and of course our old friend, radiation. There is 200 times more radiation in space than there is on Earth. Oh, and if you're looking for an interesting book about the effects of space travel on the human body, Scott Kelly's book, Endurance, about the year he spent in space studying this, is such a great read. I think they also made a Netflix series about it. Super, super recommend. Then Dr. Kaku discusses what it would be like to live on Mars. First, he says that Mars is frozen solid, which makes it really different from Earth since we've got this juicy molten core at the center of our planet. But on Mars, you only have to dig a few feet until you hit permafrost. And much like the moon, that could actually be a really useful tool for us. Drinking water, oxygen, rocket fuel. H2O is like really our friend when it comes to space travel. He proposes that actually digging into the rock for shelter offers up a lot of benefits. It's very cold on Mars, basically negative 197 degrees Fahrenheit. So it could protect us from cold and from radiation. So one way to start terraforming Mars into something habitable for man is to start digging. And since Mars's gravity is half of Earth's gravity, getting manual labor done involving heavy machinery could theoretically be a lot easier. The digging could also help release the CO2 that's locked into the frozen ground but would be released and could help warm Mars up, kind of creating a greenhouse effect, but a good one because humans need warmth and negative 200 degrees is pretty tough. And one of the other ideas that Kaku suggests is essential to colonize Mars, one where temperature and radiation is less of a consideration, is the use of robots and AI. He discusses the history of AI, which apparently kicked off in Dartmouth in 1955, and it's much more complicated than I have time to explain here. But his point is that robots and AI have always really been good at one thing: repeating a task precisely over and over again. Kaku says that robots are good with jobs that are the 3Ds: dangerous, dull, and dirty. It's the next step, pattern recognition and common sense, where robots and AI still really struggle. But using robots to help terraform Mars definitely fulfills the 3Ds and could really help make up the lack of human labor. Plus, robots don't really care about temperature and radiation the same way that people do. However, Kaku admits that more advances in AI would need to be made in order to really expand what the robots could potentially do for us. For example, robots can see better than us, but have a tougher time understanding what they see. They can recognize shapes, but struggle with recognizing objects. Robots don't create neural pathways by repeatedly performing a task the same way that people do. He mentions in the book, and I guess there's the saying in neuroscience, that neurons that fire together wire together. It's so nerdy. But that's not what robots do. And this is obviously important when it comes to space exploration, because the robots will constantly be confronting new dangers that they, in all likelihood, have never experienced before. So the ability for them to make judgments based on the information they're receiving is hugely important. But for now, the use of robots for lifting, surveying, and analyzing alien terrain will all be super useful for us. And as far as how exactly are we getting there, Dr. Kaku discusses a lot of different ideas for starships and propulsion systems. One of the ways we could get to Mars is a vessel that NASA is potentially proposing called Deep Space Transport. And its design is actually really cool. It's a series of gigantic arrays of long, narrow solar panels that kind of look like a sailboat, but for space. Spaceboat? The Deep Space Transport would use a new type of propulsion system, solar electric propulsion, which basically means that the solar panels would capture sunlight and convert it into electricity. He goes into a lot of detail on how that works, and it's super interesting. So if you want to find out more info about that, I could make another video about that down the line, or you could just, read the end of chapter 4 in this book. He also discusses another type of spacecraft called light sails, which harnesses light pressure from sunlight or lasers, and again, looks like a sailboat. He also talks about other propulsion systems, one of which was a spacecraft with ion engines, and the ion engine uses a gas like xenon to strip it of its atoms, turn them into ions, and then accelerate those ions with an electric field. He also talks about fusion rockets and antimatter starships and all this stuff, which is very much theoretical, but still a lot of fun to read about. But what about going further than Mars? If another Earth is the goalpost, does the goalpost even exist? Well, Dr. Kaku says in this book that actually the Kepler spacecraft gave us a lot of answers about that. Kepler was a huge space telescope launched in 2009, specifically designed to find extrasolar planets. It was 2,300 pounds, it had a huge 4.6-foot mirror, and it orbited the sun. It analyzed, over the 4 years that it worked, over 200,000 stars and discovered thousands of extrasolar planets. And many of them were Earth-like, rocky, capable of sustaining life, and in some cases 50 to 100% larger than Earth. And one of the planets that they were particularly excited about was one that they dubbed Proxima Centauri B. It's an Earth-sized planet orbiting Proxima Centauri, the star after our own sun that's closest to the Earth. The radius of the planet's orbit is just 5% of the Earth's orbit around the sun, which puts it in the habitable zone where liquid, possibly even oceans, can be supported. Kepler determined that 20% of stars have Earth-like planets, which makes the idea of finding another Earth far less remote. And finally, Kaku talks about how human beings can travel in space, not just to Mars, but potentially to planets that are light years away. He talks about different ideas like multi-generational ships, freezing ourselves, 2001 Space Odyssey style. Spoilers, that doesn't work. And even transhumanism, which uses cybernetics to change or augment our physical abilities. He also talks about how human life expectancy has really changed in the last 100 years and probably will in the next 100. In 1900, the average life expectancy was 49. In 2020, it's nearly 78. Now, an extra 30 years of life expectancy is hugely helpful when it comes to long-term space travel for a whole host of really obvious reasons. However, with that longer life expectancy comes a huge boom in population, which of course leads to overpopulation. Dr. Kaku says that for most of human history, human population was well under 300 million. And with the Industrial Revolution, it grew to 1.5 billion in 1900. Today, we have 7.5 billion people on this planet, and the UN estimates that by 2100, it could be 11.5 billion, which kind of leads us back to Carl Sagan's quote, "Humans, for the sake of their own survival, should become a two-planet species." And again, since we're talking about space exploration, inevitably, the big question of meeting those who are not from our planet is gonna come up. But if you're gonna talk about the whole alien question, what I really enjoy about this book is its really practical approach to this question. And one of the funniest sections in the book is he talks about, like, what's the plan? What is the actual plan if aliens were to land? Like, we get a couple of UFOs that touch down in Saskatchewan and the aliens emerge. Like, who's in charge? Do, like, the Canadians deal with it? Does the US, the UN, the Joint Chiefs of Staff? Like who is in charge? What are the protocols? So he spoke with Dr. Seth Shostak of the SETI Institute, who confirmed that there is absolutely no plan of any kind, and that scientists had made, informal suggestions to various governments, but because the governments don't take any of this seriously, there is no policy in place at all whatsoever. And for some reason, his really practical approach to that just really made me laugh. I thought it was super funny. But he also talks about what he thinks aliens could look like from an exobiology standpoint. Obviously, he says that they can look like anything, but there are higher probabilities of a few things. Life in outer space, just like it did here on Earth, could come from the ocean. So there's a high probability that the aliens could be made up of carbon-based molecules. The chemistry of this would allow for an ability to store vast amounts of information and also for self-replicating, which is two pretty important criteria for sustaining intelligent life. He also discusses that they are likely to have stereo eyes, which basically means eyes that face front as opposed to eyes on either side of your head like a fish or a deer. And this is presumed because predators are more intelligent than prey, and predators' eyes tend to face forward, and he thought that there would be a high likelihood that intelligent beings would descend from predators. He also says that they are likely to have some sort of grasping appendage in order to shape their environment, as well as have some sort of language. But aside from that, he admits it's like pretty much it can be anything. But of course, this inevitably begs the question, the infamous Fermi paradox: where are they? If they exist, why do we have no proof of their existence? However, Kaku speculates that if they have the ability to reach planets that are light years away from them, then obviously their tech is much more advanced than ours. So to them, we would look incredibly backwards. So he asks, why would they try to communicate with us if we have nothing to offer them? He says it's like going into a forest and trying to talk to squirrels. If the squirrel doesn't answer back, you're going to give up pretty quickly. He thinks that we would be nothing more than a primitive curiosity to them, and it's the arrogance of man to think otherwise. So I feel like he's basically saying, we're not that big a deal. Fair. The end of the book also discusses Planck energy and wormholes and a lot of things that were brought up in QGR's doc. So if you're interested in that more than the alien stuff, then the end of this book definitely has some interesting things in it too. And finally, he wraps up the book by going back to that optimistic premise that I mentioned at the beginning of this video. And he tries to answer the question, what is the future of humanity? Well, our future is sort of tied to the universe's future, and Kaku says that it could go one of three ways. That the universe will end in either a big crunch, a big freeze, or a big rip. The crunch being the expansion of the universe slows, stops, and reverses. Temperatures rise, stars get closer, and it's the Big Bang all over again. Freeze, meaning the universe will continue to rise unabated and the universe will get colder as heat and matter grow more diffuse. Stars cease to shine, night sky is totally black, and we all freeze to death. And finally, rip, which is basically the big freeze on steroids. Entropy increases and galaxies move so far away from us so quickly they exceed the speed of light and disappear from view. Literally, the galaxy and solar system is torn apart. And as dreary as all this seems, I think Kaku's point is like, look, life is sustained, wonderfully so, in the universe as it is today. So to think about man's future and long-term sustainability is our privilege, but not one that's guaranteed to us forever. The universe, just like seasons and species, has its cycles, and this one will not last forever. So thinking about how we will continue, knowing what's out there, knowing what we know, will define us. But it's certainly our choice. He then ends the book with a couple of quotes, and one of them is by Stephen Hawking, which says, "Our only choice of long-term survival is not to remain lurking on planet Earth, but to reach out into space. But I am an optimist. If we can avoid disaster for the next 2 centuries, our species should be safe as we spread into space. Once we establish independent colonies, our entire future should be safe." Thanks, Stephen. I needed that. So clearly, I really enjoyed the book. Big thumbs up from me. I love the practical approach to the fantastical and not so fantastical topics that he discusses, and I think it's a really fun read. But I'd love to hear your guys' thoughts on any of the ideas I talked about today, or if you've read this book, or if you just want to say hi. All of that's good too. Please do so in the comments below, and I will see you guys in the next video.